Hello, SGD Sacred Geometry Decoded. I'll put links in the description because it relates to other playlists and videos, so especially in regards to the plateau and how not just the Menkaure, Khafre and Khufu pyramid, but also how the Kent-Kawe pyramid form this astronomical, actually a yearly calendar which marks the solstices, especially the summer solstice, where the sun sets directly between the Khufu and Khafre period, marking the Egyptian New Year, or the first day of Akhet, the flood season. Also, the imagery from that site connects. So, if you follow the Khafre Valley causeway down to where it touches the Khafre Valley Temple, not just for this solstice equinox viewing point and the meteorological connections, how it joins the whole plateau and is just geometry, and links many other things: the distances, the proportions, the angles between the three of the Great Giza pyramids, but also the Kent-Kawe pyramid. But from this observation point, this 0 point where the causeway touches, is another important feature. So, for instance, the view there, you can see there's a little doorway, and right at that doorway, it's just a perfect position in terms of the length, the measurement connections, the observation points, but it's important. So we have the Great Pyramid, or the Khufu Pyramid. So this video is going to be an alternative way to draw it. I've done others where you have the cross section, but it's using this temple and how it perfectly marks, right between here, the sun sets right in the middle, it's a perfect depiction of Akhet. So as sunset, so what you see is the Khafre Pyramid and the Great Pyramid, or the Khufu Pyramid. The sun sets right between them on the summer solstice, marking Akhet, the flood season of the New Year. The symbol for Akhet, for the New Year, just matches this description as seen from the 0 point, ground zero, let's say, as well. But the important point is that viewed from that point, now because of the angle of this picture, it's slightly out, but you don't see the side of Khafre. What you see is the cross section. You see just a triangle. But pyramids, of course, are three-dimensional objects, and so viewed from this point, what you see is the base. You see two sides of the pyramid. So the angle, what we see there is the corner angle, and we can draw that with some lovely geometry. So again, the Akhet season. Now, the angle that you would see, or the corner angle of a pyramid, there is 42 degrees, and therefore right angle triangle, the rest would have to be 48. So usually when people look at the pyramid, they think of the 7-11 proportions. So that would be the cross section, 280 cubits high and 440 wide, or a 11:7 ratio. But again, I've got just a little cutout of the JH Cole survey. So for instance, the southern side, which is the longest, is 756 and just a fraction over. The shorter side is just a fraction under 755.5 feet. There's about a 19.20 centimetre difference between the north side, which is the shortest, and the south side, which is the longest. So this difference will slightly change the angle. So based on the 7-11 idealised proportions, so again, viewed from that point, we would see like a cross section of Khafre pyramid, but we see the corner of the Great Pyramid. And again, that's a 42 degree angle. Strictly speaking, off idealized proportions, 11 wide by 7 high, that angle is 41.986 degrees. But again, there are slight variations on each side. And even if working on the idealized 41.986, that's 14 hundredths of a degree from the perfect. But if you include the slight variations, it all comes together and works very nicely. So the angle that's most often mentioned is a 51.84 degree slope angle, the apophthegm, but the corner angle of the pyramid, so the pyramid again is not a triangle, it's actually three-dimensional, and so you get this 42 degree angle, and we can draw that from the 5/6. So we draw a pentagon and we draw a hexagon, and the angles that are encoded in there will give us the angles we need to draw this alternative view, the corner view of the pyramid. And that's also a nice connection to the bent pyramid. I'll put an animation following this, but the angles of the bent pyramid, if you unfold them, create a beautiful connection between the hexagon and the pentagon. And I'll put a little animation up just to show that a little bit more clearly, and then we'll start the drawing as well. So again, even the Hermetic alchemical tradition in regards to 5 and 6, the macrocosm and the microcosm, and these constructions lending themselves to many other aspects. I'll also put a link in the description where I talk about the 42 and 48 degree angle and how they encode Pythagorean harmonics. Lovely connections there. Even 42 degrees, such as the famed 42 gods in Judgment in the Book of the Dead, or even as late as the 3rd century AD, the followers of Thoth, the Christian archbishop there in Alexandria, even up to the 3rd century AD, was noting that they were still carrying the 42 sacred books of Thoth as well. It's one of 42 being the answer to everything, as for in the Hitchhiker's Guide to the Galaxy, and also one of those lovely numbers. But it's pentagons and hexagons back to the Great Pyramid, and also again we'll show the link in regards to the bent pyramid and the 6 and 5 connections. So here is an example. We have 4 pentagons. That section where they form around a square, we can create the top half of a bent pyramid. So we fold those in, and what we get is the top portion of the bent pyramid. Now we have the 5, the pentagon, and we'll come to the 6 or the hexagon as well. So 4 pentagons from their centers, the triangles, which 1/5 of a pentagon. There we have the top section of the bent pyramid. Now the bottom section is a series of unfolded portions of the hexagon, the same practice. So a hexagon being 6 equilateral triangles. So the bottom section of the bent pyramid is just a series of equilateral triangles that have been bent upwards to form a pyramid. Then of course that's been cut off, and then we have the red section there on top. But there's a nice connection to the platonic solids there, the seed of life, and of course that hexagon construction, which we'll show I'll show in the video in a moment on how to do that. And then again, that's embedding the same angles that we can get to find the corner angle of a Great Pyramid. So that if that bottom section of a bent pyramid had been completed at that same angle, what you would have is a perfect pyramid. Actually, no, sorry, it's not a perfect pyramid, but it's made up of equilateral triangles, or 1/2 of a octahedron, one of those platonic solids. And if you twist an octahedron and look at it at the right angle, you actually get a hexagon as well, which I think is a lovely connection to this type of geometry as well. So when, again, it's how the 2 and the 3 dimensions apply together, and coming to that point as we'll draw the pyramid from the corner, rather than thinking of it as a triangle, think of it as a pyramid. It has many sides. You can see the most you'll see is 2 sides from ground level at once. And so now let's do the construction, and we'll draw the Great Pyramid from the corner angle. Hello SGD, Sacred Geometry Decoded, and another drawing exercise, but let's look at an alternative way to draw the Great Pyramid. So we won't be drawing the slope angle, we'll be drawing the corner angle, which is the one that's so applicable to the Giza plateau, being a observation point for measuring the solstices, and for instance when the beginning of a flood cycle begins on the northern hemisphere summer solstice, is going to come from the connection of the 6 and 5, the microcosm and macrocosm, or the pentagon and the hexagon. So we'll begin with a construction line, and we'll begin now with a vesica. Okay, how big can I make it? So actually I can go off the side here. I'll try to make it large so it fills up the screen as much. Now begin with a vesica. center of the second circle on the edge of the first. Once again, we use this as this template. So the first thing is to create so we're going to draw a perfect pentagon from this, and then use that as a way to draw a hexagon, and then from those angles we can draw the Great Pyramid from the corner angle, which is the one which is observed from that important 0 point. Now, you don't actually need to draw a whole circle, but I will. So now we have this third circle which is centered there. Now that also gives you the template for a square. The square will be tilted, but I want to keep this compass. I could change the setting, but just for simplicity, what I'm going to do now is, so again, we'll define this length as 1. Is that the case, or is it, yes, we'll define anyway, but if, okay, that would have to be 2. Yes, so that's 1, that is 2, so this triangle, the hypotenuse would have to be the square root of 5, and we need to set the compass to that setting. So put your point there, set the compass to that point, and you only need to draw an arc to cut. You only really actually need to mark there. So what we have is the square root of 5 plus 1 and square root of 5 plus 1 over 2 equals 5, a golden number, 1.618. So what we have really there is 2 phi. That's not so important for the moment. So now I'm going to go back to the original. I haven't changed it. I could just have set the compass again and place it there on the edge and draw an arc, and what you have is, voila, you have a perfect pentagon. So I'm going to draw it in very dark. Okay, now what you really need is this point here and this point here. I've tested this on GeoGebra, and so we're going to run a line from that point through there. Same point, and this. Now from this point through there. And from that point through here again. Perfect pentagon you should have. So you have all those phi proportions. Now, because of the thickness of the pencil, this, I think this point actually touches there, but again, I've tested on GeoGebra, so that should be, let's do a very rough test. And we begin with that distance. Okay, they should all be equal, yes. So as I thought, if I was to have, because of the thickness of the pencil, I think this would actually be touching that point. If I remember rightly, it's been a few months since I've drawn this, but if you follow the technique, you will get the perfect construction. It'll be equal. Yes, so put that draw. So you follow the rules of it, but we want to draw the pyramid. Now what we need to do is, so we have our pentagram. Now if I was just to join up those lines, I would have a pentagon. But the only really points you need here is this side of the pentagon. I could rub this line out. And what we do is we set our compass. So we're going to have a pentagon and a hexagon with equal edge lengths. Okay, so now I can So that circle was neatly there. And so I'm just going to draw a seed of life. So I already have one circle, two circles of vesica, the third is the Trinity point, and we just can run that around. And one more circle, we get the full seed of life, so you see the effect of it. Okay, so there we have the petals of the seed of life. One at the tip of each of those petals, you join them together, you have a hexagon. I'll put the links in the description just to the earlier version. So I think because I was just being quickly, I've got like a dark blunt point. So, but it does it is a perfect pentagon, precisely 108 degrees. So you get all the connections to the golden ratio phi and pi. Might as well draw in the pentagon. And now we can. I'll put some links into the Great Pyramid AIP channel because he's been looking at the connections between the 5/6 ratio and as it applies to the pyramid. There's some interesting videos if you haven't subscribed to the channel or seen that, but we have a perfect pentagon, we have a perfect hexagon. Now we have a way to draw the Great Pyramid, and not the slope, because using the phi ratio, but this is another way to look at it, and I think this is an important way, especially in regards to the Khafre Valley Temple and the Khafre Causeway, and how that lends itself to the wider plateau at Giza being an astronomical marker. What turns out is that this angle is 24 degrees. So I'm going to draw a. Actually, I still have that arc there. I'll just draw that circle dark. You don't even need to do the whole circle, just a portion of it. So that is 24 degrees. So now set your compass to, actually I'll put it here. Set the compass to that 24 degrees of arc. Mark it. Okay, so that's another 24 degrees. Therefore, the entire thing is 48 degrees. Okay, now, rather than do it, because I could now draw another, I just want to now find the horizontal from there, and I'll cheat a bit because I'll use a set square, but the last video I did will show how to create a set square. That 90 degree angle, so it's not technically a cheat because I've already shown how to do it. Okay, so since that's 48, this angle here has to be 42 degrees. Now let's tilt that sideways. Okay, now again I'm going to use a set square to cheat a bit. Okay, so that's 42 degrees. Now I can extend this line. And I'll just take that distance and run it over. So join that to the peak. So what we have is this triangle, which has an angle of 42 degrees, which is the angle of the Great Pyramid viewed from the corner. Viewed from the cross section, it would be 51.84 degrees. But viewed from the corner, which is that point, which shows the summer solstice connection between Khafre Pyramid and the Great Pyramid, you're actually viewing it from the corner. So that's like your straight on view, but if you were looking at the pyramid from the corner, this angle would be 42 degrees, which is also a lovely number. You know, 42 books of Thoth / Hermes, Trismegistus, etc. I'll do a little rant and showing what I mean by that 0 point and how it's a solstice equinox marker and points to the flood, and it's viewed from that position. Is what you see the corner of the pyramid, and so the Great Pyramid is 7 by 11 high, which is very, very close to pi over 2, but viewed from the corner, what you have is 11 plus 7 high, which gives you a 22 over 7, which is pi, the golden number. Now 22 over 7 is an excellent approximate because the Great Pyramid itself has a slight variation, and viewed from this side, the southeastern corner, it is pi. It's even more accurate than the idealized measures because it's not exactly 440 cubits on each side, but that's another point. So from the first we get a perfect hexagon, perfect pentagon or pentagram. There we get the 6 over 5 of a macrocosm over microcosm, as alchemists, hermeticists would talk about, and then from there we get the 24 degrees, and then that leads to 48 degrees, and therefore we have the 42 degrees of the pyramid viewed from the corner. So I've done other videos showing how to draw the 7 to 11 proportion, or even a Kepler triangle, which is it's almost identical, and again, because there's slight variations on each side of a pyramid, you could use it is a Kepler triangle in that it's a square root of phi and 1. But 7 to 11 is very, very close to that as well, but the pyramid is not equal on each side. There's between the south side, which is the longest, and the north side, which is the shortest, there's about a 20 centimetre difference between the two, and that variation turns excellent approximates of pi and phi into statistically insignificant from 100% perfect. So just another drawing exercise. You get Pentagon, Hexagon and Great Pyramid. Have a good one. Cheers.